Hello class. Today's video is going to be on polygons. This is the start of chapter 8 in our textbook, and this whole part's only going to be section 8.1, and we're going to take a quiz on just section 8.1 when we're done. So, what is a polygon? A polygon is a closed plane figure formed by 3 or more line segments called sides. So since it's by 3 or more line segments, the smallest polygon we can have is obviously our triangle. The other thing you should remember about polygons is that what also makes them a polygon is that the vertexes only ever have 2 line segments going to one vertex. So sides are called sides, and then they meet at vertexes, and we should only ever have 2 line segments meeting at a vertex. And why I say that is because it's going to bring us to a pictures like this. Obviously, this is not a polygon due to the fact that it's open. This is not a polygon due to the fact that it has a rounded edge. This is a polygon. It's closed. This is a polygon. The reason this is not a polygon is because if you look at this vertex, there's 3 lines going to that vertex. So that is not a polygon. All the way down, not a polygon because of rounded, not a polygon because 3 lines go to one vertex, and then not a polygon because of rounded. Everything else is a polygon on here. What you are expected to know is the names of various polygons. So for example, obviously our most common, smallest polygon we can have is a triangle. When it becomes 4 sides, you don't want to get specific. You don't want to say square because a 4-sided figure is a square, a rectangle. So we want to call them quadrilaterals. 5-side is what we call a pentagon. 6 sides is a hexagon. 7 sides is a heptagon, not septagon, okay? Not because it begins with an S, so we call it septagon. It's a heptagon. 8 is your octagon. 9 is a nonagon. 10 is a decagon. I'm not even positive what 11 is. 12 is what we call a dodecagon. 2 do on top of 10, so dodecagon. And then anytime we don't have a name for another figure, actually on your note sheet I see there is 15. We call that a pentadecagon, is 15 sides. And besides that, because the textbook uses pentadecagon a lot, but other than that, you just have to be able to pick them out, or possibly if I said what's the name of a 7-sided figure, you would need to say heptagon. If it is anything besides these, we just call it an n-gon. So we just call an n-gon. So if it had 11 sides, we would just say 11 gon. If it had 20 sides, we say 20 gon. So a polygon is considered convex if you extend each side of the polygon and there's no segment that goes through itself. So what that means is if I draw a line here, this line tracing the sides of this never go into the interior of the polygon. That's what a convex polygon is. If the polygon is concave, it caves in on himself. But if I take a line segment and I trace one of the sides, now this line segment right here has gone through the interior of this polygon. So that is why it's concave. So cave in, that's pretty easy. Normally they will cave in, but as long as those caves don't go through the interior, it could be convex. But most times if it caves at all, it's going to be concave. So let's look. Concave or convex? First of all, trick question, not a polygon. Actually, so it's not a polygon. If it was, you would say that it is concave, but it's not a polygon. This one, because this line, if I extended it out, would go through the interior, that's concave. This one is convex. And this one, because it caves in and that line would go through the interior, that is also concave. I would say this slide is probably the most important slide of your entire note sheet, because I feel like you should have already been introduced to the other stuff. And in this one, this might be new to you. You have to understand, if a polygon, so in an equilateral polygon, all the sides are congruent. And in an equiangular polygon, all the angles are equal. So that's pretty easy to understand, that equilateral means sides and equiangular means angle. But if a polygon is both convex, equilateral, and equiangular, then we call that polygon regular. And this is very, very important, because we're going to talk a lot in this chapter about regular polygons. And if it's not regular, it's not going to work. But if it is regular, it will work. So you got to make sure you understand that the definition of regular is convex, equilateral, equiangular. And a regular pentagon is right here. All of these are regular polygons. They're basically your most typical looking shape. So let's look at, I asked you in this one just to classify the polygon, tell whether it's equilateral, equiangular, or regular. So regular, which means it's both. It's both equiangular and equilateral. And then lastly, let's look at an algebra style problem. The head of a bolt is shaped like a regular hexagon. So the fact that in the description I told you it's regular, you should now know something about the sides. The expression shown at the right gives you the side lengths. Find the length of a side. So I know this side is represented by this and this side's represented by that. So I can set them equal. I find x. Please note you're not done in answering this question. So x is 4, and then I need to plug it back in to say that 4 times 4 plus 3 is 28. So a side of the bolt is 28 millimeters. Also, I've seen questions like this that ask for the perimeter. So you would find that each side's 28, and then you would take 28 times 1, 2, 3, 4, 5, 6 sides, since it's a hexagon. Okay, that's our video on polygons. I remember the most important slide is you have to understand regular, what that means, and then second of all, you need to know the names of these polygons. Thank you.